Uranium mining is being proposed for the Coles Hill area near Danville, Virginia. Water supplies could be impacted downstream, including the supply for the Virginia Beach area.
We're now going to hear 3 to 5 minute presentations from these 5 world experts, all of whom have lived and breathed the situation with uranium mines, not only here in the United States, but all over the world. They have written and spoken extensively. They have offered testimony to legislatures here and around the world, and they really know what they're talking about, and they are trying to provide the kind of in-depth information about the impacts from uranium mining.
And I'm a native of Virginia from Rockingham County, so I'm particularly pleased to be in Virginia to discuss this important issue at this time before there's irrevocable decisions made about the generation of a nuclear waste repository that the uranium mill tailings would become were they to be generated at the Coles Hill site. The deposit is found at the upper end of the Bannister River watershed, which is a tributary to the Lake Gaston that provides water to some of the communities in this region. The deposit is in a very wet setting and will require dewatering. It will require pumping out water from an open pit or from an underground mine, and that water will require treatment before discharge. That's going to be a very likely source of water from the uranium site into the Lake Gaston watershed. There may also be discharges from the mill processing itself, but the larger volume of water is going to be coming from the mine. The mill will be able to recycle most of its fluids. One of the gaps in Virginia's regulatory program that was identified in the early 1980s was the lack of mine reclamation requirements. Virginia has made no progress on that area of legislation or regulation. Since that time, the world has recognized many of the problems with uranium mill tailings and established uranium mill tailings legislation and regulation, but not address the mines. The ore that comes out of the ground in an open pit can only be removed after there is overburden removed from the top. That overburden is typically 3 to 5 times the volume of the ore. And then the ore, if it were mined, would have about 0.2% uranium. That's 2 cents out of $10. $9.98 is the waste. 2 cents is the value. So I say that mines and mills make waste with a little byproduct uranium, and it's the waste that's left in the communities as a potential source of radioactive and non-radioactive contaminants in perpetuity. So the communities get the waste, the company gets the uranium. The world has more than enough uranium for all of the needs it could identify for another 85 to 100 years. According to the World Nuclear Association, a trade association representing the reactor industry. The association wants reactor operators to recognize there's no shortage of uranium, and there's no likelihood of the reactor operators being held hostage to a lack of uranium. The U.S. also has produced substantial amounts of nuclear weapons from uranium and is working actively with Russia to dismantle those weapons and reuse that weapons-grade uranium for reactors. That's a very large source of uranium, and it represents several large uranium mines, according to the Uranium Exchange Consulting Company, which is an international uranium pricing institution.
I need you to know, and Paul touched on this, and I think other speakers will as well, is that uranium is a radioactive element. It's been around a very long time. And it decays, and it decays very slowly, a little bit at the half-life of 4.5 billion years. But when it decays, it goes through this what is called a decay series. And so you get thorium, potassium, all of these are radioactive, and they all, when they decay, when they give off radiation, they turn into the next element. Another form of uranium, thorium, radium, radon, and then all of these down here are called the radon daughter products. Radon, of course, is a gas, so it seeps out from the rock and ore that the uranium is in. floats up into the air, has a half-life of only about 4 days, decays, turns into solid particles that then can be inhaled into our lungs. And radon is a very potent carcinogen. We know a whole lot about its health effects. For uranium, there are some well-established health effects from the toxicology literature. Toxicology is usually done in animal models or in cells grown in culture. And kidney damage from uranium from animal studies goes way back in time. It's very well documented, very clear. No question, uranium is seen as a classic nephrotoxic chemical. Also, in more recent years, developmental defects, that's birth defects in animals, have been shown starting in the late 1980s into the 1990s. These are oocytes viewed through a microscope. And what you can see here is that in the square labeled A, the oocyte is healthy and normal. It's the way it should be. All right? It's what an oocyte would like to be. All the rest of these are abnormal in one way or another. You can see this little polar body is missing in B and so on. And it was the ones that are that have a blue or turquoise circle around them, those are the kinds of changes that they found were more frequent in oocytes in mice that had been exposed to uranium. Okay? So this just sort of makes it, I hope, makes it sort of visual. Here we have mice, they're exposed to uranium, they took out their oocytes, they looked at them under the microscope, and they could see visually increased damage in those that were exposed to uranium of certain types versus other types. Similarly here for autoimmune disease, and again you can see, in this case the red is more like 4 times increased risk of autoimmune disease. Again you can see around these mine clusters much higher risk of having autoimmune disease. All right? So these are mines that were created in the past, but they're still around today, and people have been living there a long time. And this study at least has preliminary evidence that, that people living closer to the mines and more proximity to the mines and the abandoned waste of the mines also have higher health risks. Now this study has many more steps to go. They're going to analyze uranium in urine, and they're going to there's a whole bunch more things, and so this isn't at its end, but at this intermediate stage, it's suggestive, it's more evidence suggesting that living next to these mines increases health risk.
France does not have the answer to all the problems linked to nuclear energy. They started uranium mining around the same time as the rest of the world, mainly looking for uranium to use in nuclear weapons. And they started the mining in France itself, because they have their own deposits over there. However, in the 60s, first of all, the ore quality in France started to decrease, so it became more difficult and less efficient to mine that ore. And at the same time, there became more public awareness and more regulations around the uranium mining impacts and the impacts of the radioactive pollution linked to that. There was more and more criticism about how would the wastes be stored, how would it be safeguarded for the longer term. And that was one of the reasons why France had to look to other countries to start mining. So we managed to look at the uranium mining impacts on the air, the earth, and the water. We took water samples, especially from drinking water wells that are used by the population. And we compared those with water sample that we took in the area of the new mine, where the mining operations have not started yet. And it was very clear that the contamination present in the water that is used by the communities in the villages is much higher. There's higher levels of uranium and other contaminants in the water than anywhere else further away from the mines. Walking the streets of Akokan with our radiation monitors, we found at several places high levels of radiation, up to 50 times normal background, 500 times more normal background. This woman, she's from one of the local NGOs. She's saying, Arriva is coming to our country and making money, but we are the ones suffering, which is what everybody tells you. They identified illnesses that have never even been there before. They don't know where it's coming from. They can't prove that it's influenced by the mine. But of course they are worried.
Examples of Niger that my friend was talking about is very useful, even though that area is one which is dry and not climatologically similar to Virginia. She's describing current practices by one of the world's leading nuclear corporations, Areva. That's not ancient mining that a company isn't doing anymore. Open tailings are dumped on the ground. There is no pollution prevention strategy in place there. They're I think, showing the quality of the industry, which will go to the weakest link. When industry says there's good regulations in place, they don't say that they sued to prevent those regulations from being enforced when they were proposed in the mid-90s. And they don't say that they're going to try and use whatever discretion is allowed in those regulations to the maximum. Regulations themselves are not protective. It's the way they're implemented. Does Virginia have the resources to implement in a way that prevents pollution? There hasn't been much progress on that since the last time uranium mining was considered in Virginia more than 25 years ago.
We have the distinction of being the oldest continuous inhabited village in North America. Growing up in New Mexico, in our community there, which is situated in the heart of the Grants Mineral Belt, was one of the largest ore-producing areas in the United States from about the late 1940s to the present time. In this learning experience, in this 50-plus year legacy, we have found that the federal government of the United States has been very slow in cleaning up these impacted areas. Situations of environmental racism that have left us with contaminated soils, contaminated air, contaminated water, impacts to the flora and fauna, impacts to both domestic and wild animals within our homelands have also been threatened by the uranium industry. In the desert Southwest, water is a very important resource that we rely on. And in this development process of uranium mining and milling, we have seen our watersheds contaminated. We have seen the impacts of the development process impact the quality of our waters through runoff from being situated downstream and downwind from these mines and mills. Remember our legacy. As our elders have told us, this is a point of no return. Leave uranium where it belongs, in the ground. As I drove from Richmond to Norfolk today and saw the beautiful woods, the beautiful water sources that you people have here, why would anyone in their right mind want to destroy this beautiful part of our mother, the earth?
In Ontario, for example,